the 2018 paper for Junior Cert question 6, the functions question, was quite a long one. Right, a sheet is folded in half a number of times. H of x here is equal to 2 to the power of x, is the number of layers after x folds. Part A asks you to fill in the table to show the number of layers after each of the first 6 folds, okay? So 2 to the power of x. Okay, that's my function. Okay, so you have 2 choices. You can put your calculator into table mode. And if anybody doesn't need to know that, hop on your mic and I'll explain it, and use this as your function, or you can do it manually. So for this one here, okay, x is 1. So in my function, x is being replaced by 1. Okay, so for this one here, I would have 2 to the power of 1. For this one here, I would have 2 to the power of 2. For this one here, I have 2 to the power of 3. So this is the one that you might realize you've done a mistake, okay? Because it's very easy to put in your function as 2x. Okay, 2 by 1 is 2. That's the same as 2 to the power of x. 2 by 2 is 4, but that is also the same as 2 to the power of 2. 2 by 3, though, when I get to this line here, 2 3s are 6, but 2 to the power of 3, if I was to write that out the long way, that is 2 by 2 by 2, 2 2s are 4, 4 2s are 8. So it might be this line before you realize that you have put it into the calculator wrong, or you're putting it into the calculator wrong. So always check the answers that they gave you to make sure that you're doing the right method. See if you use your method, are you getting their answers? Okay, so this way is wrong. It is not 2 by x, it's 2 to the power of x. 2 to the power of 4 is 2 by 2 by 2 by 2, but you can put it into your calculator using 2 to the power of x. If you wish, make sure everybody can find that. 2s are 4, 4 2s are 8, 8 2s are 16. Okay, so 16, you should get 32 for 2 to the power of 5, and you should get 64 for 2 to the power of 6. Okay, so that's how you do that first part A. Okay, part B then asks you for list the elements of the domain and the range of h of x that are shown in the table above, okay? And this is why I wanted to do these questions, was to show you that you do need to know what's known as domain and range. So another word for domain is the inputs, another word for range is the outputs, okay? So if this is your function, 2 to the power of x, what are we feeding into the function? Well, we feed in our x values, okay? Isn't x the value that changes in all of these? So our inputs are 1, 2, 3, 4, 5, and 6. Okay, squiggly brackets around them, commas between them, and in numerical order. Okay, and in the same way then, your range is a fancy word for your outputs. Aren't these ones here my outputs? Because this function gives me the number of layers. Okay, and h of x, when I replace x with each of these values, it is giving me the number of layers in after so many folds. Okay, so 2, 4, 8, 16, 32, 64. Okay, so there your domain and your range. Okay, and you have to know what they are. Okay, so your inputs and your outputs. Let me just clean up a small bit. Okay, so there was 10 marks in your junior cert for part A and B together. They were worth 10 marks. Okay, and then C and D then were worth another 10 marks. Work out the least number of folds that would be needed to have more than 500 layers. So how many folds do I need for 500 layers? Okay, and you can do it mathematically, but you can also just do it, either guess it or keep going with your table. Okay, so if I do 2 to the power of 7, I am going to get 128. How am I doing this fast? Well, it's the previous answer multiplied by 2. If I do 8 folds, then how many layers do I have? 2, 5, 6. If I do 9 layers, then how many do I have? Well, 128, 6, 5, 1, 2. Okay, so therefore more than 500 layers. So I would need 9 folds. Okay, I hope that makes sense. You could, of course, guessed, you could have done it by trial and error, okay? Trial and error is always an acceptable way to do maths. So you might have guessed 2 to the power of, we might have guessed 2 to the power of 10 and put that into the calculator and see what you get. And for 2 to the power of 10, you would have got 1024. And you see, oh my goodness, that's too big. You might have done 2 to the power of 8 then and got 256 and saw that was too little. And then figure out 2 to the power of 9, 512, and then there's your number of folds. Okay, and that's a perfectly acceptable way to always do maths. It's called trial and error. Work out the number of layers after 12 folds. Give your answer in the form a by 10 to the n, where a is an element of OR and a sits between 1 and 10. Okay, so work out the number of layers after 12 folds. Okay, well, 12 folds, so x is 12, okay, because isn't x number of folds? We see it up here in our table. So therefore, h of 12, in other words, how many layers have I for 12 folds, is 4096. Okay, give your answer in the form a by 10 to the n. Okay, so I'm just going to clear off the trial and error bit now again. It's in the recording, so don't worry about it if you prefer that way. It's always there. Okay, because I want to play with a by 10 to the n. Which is what we call scientific notation. So if I make up a number, which is 1, 2, 3, 4, 5, 6, okay, are you okay that I can write that number as 1, 2, 3, 4, 5.6 by 10? Okay, are you okay that that's the same number? Okay, my decimal point moved back a place, but I'm going to end up multiplying it by 10. And if you put that into the calculator, you should see that you get the same number as here. Okay, I could also write it as 1234.56 by 100. Okay, and again, if you put that into the calculator, you'll see that it's the same number as this. Now I'm going to go one step further with this one, and instead of 100, I'm going to write that as 10 squared, because 10 squared is 100. Okay, so that's one way of writing the number. That's another way. That's another way, either of them two. Are you okay then that I could go 123.456 and multiply it by 1,000, and 1,000 is 10 to the power of 3. And in the same way, I could go 12.3456 by 10 to the 4, or of course, I could go 1, 2, 1.23456 by 10 to the 5. Okay, so all of these are the exact same number. This way, this way, this way, this way, this way, this way, this way. They are all the exact same numbers. There's just different ways of writing them. Sometimes we write them as in this, and then we'd round this. Okay, it's just sometimes easier to say 1.2 by 10 to the 5 than it is to say 123,456. Okay, so scientific notation can be used to, I suppose, make big numbers easier to say or to make small numbers easier to say. Okay, so that's scientific notation. Now, what does it mean a by 10 to the n? Okay, well, any of these numbers here are a by 10 to the n. A by 10 to the n, a by 10 to the n, okay, and a by 10 to the n in this case is just 1. Okay, so all of these numbers are already in the form a by 10 to the n. But how do we figure out which one is the right one? Well, we look at the next condition they have there. A must be between 1 and 10. Okay, 1 is less than or equal to a is less than 10. Okay, so they want my number, this number here, to be between 1 and 10. So now there's only one option there. I'm looking down through all of these numbers to find the one that's between 1 and 10. And I get this one here. Okay, because 1.2 as a number lies between 1 and 10. 12 doesn't, 123 doesn't, 1234 doesn't, and these two definitely don't. So the only one is where the decimal point lies between the first two numbers, unless of course that's a 0, but in general it's not. So when the decimal point lies between the first two numbers, you will find that the number is between 1 and 10. Okay, so that's it in general. That's just scientific notation in general. And it comes up a bit, so I hope it does make sense to you. Okay, so how do I do 4096? Well, where am I going to insert the decimal point in this? Let me just change to a light color. Okay, so the decimal point always sits after a number. So I go 1, 2, 3. Okay, so that number in scientific notation is 4.096. Now, how do I figure out what my n is? This number that's here. Well, it's tied to how many frog jumps we did from here. So I did 1, 2, 3 frog jumps, so it's 10 to the power of 3. Okay, as an aside, if you put 4.096 by 10 to the power of 3 is 1,000. Okay, if you put that into a calculator, you will see that you get that 4096. Okay, and that number is in the form a by 10 to the n, where a is between 1 and 10. Okay, explain what the following statement means in terms of folds and layers. So they want to know, do you understand what was meant up here? Do you understand what's meant by folds and layers for this particular question? And it's up here. 2 to the power of x is the number of layers after x folds. So just read the statement and see, can you put English on the maths language? Okay, so this is h of x, this is h of 14. So now in that, I can see that x is equal to 14, okay, and whatever it's equal to, h of x is the number of layers. Okay, so the number of layers is greater than 10,000. Okay, so let's explain what that means. Okay, so I would say that the number of layers, so whatever way you want to say it, after 14 folds, the number of layers is greater than 10,000. Okay, or something like that that makes sense, you know, in your head. Okay, and then F, place a tick in the correct box to show what type of pattern is made by the number of layers. Okay, so there's a few different types of functions on your course. There's a linear one, and that's when it'll be a graph. It goes up by the same amount. There's a quadratic, and that's normally where the values decrease and then increase. Okay, and then there's an exponential, which the numbers either grow drastically or of course can fall drastically. Okay, so you can have negative or a positive exponential growth. Okay, so I look at these here and I go, are they going up by the same amount every time? No. Okay, so that is not a linear graph. Okay, we can immediately get rid of a linear. Okay, is it a quadratic? So are the values increasing? Yes. So I can see that they're increasing like this, like a quadratic would, but they just keep going. They never actually turn back down again. Okay, so they're increasing, but you'd expect them to come back down at some stage, and that's not happening. Okay, so I would say it's not a quadratic. It is an exponential curve. So the nature of an exponential curve is that it starts off slow and then takes off, okay? Or starts off slow high and then ramps down. So, for example, COVID cases is the perfect example of an exponential curve. And you may very well get something like this next June, because remember, they'll be writing your exam papers after Christmas and we'll still be in the throes of COVID. Okay, why is COVID exponential? Well, one person gets COVID and they pass it on to a few different people. Okay, now each of these people then have COVID, and if they are in close contact with others, they spread it on. Okay, now all of these people are infected, and of course, even if they're only in contact with 5 people in their bubble, each of these gets 5 cases, unless, of course, all the hand washing and everything was done. Okay, and so on and so forth. So from that one case, we ended up with this sweep of COVID cases, okay? And that's why when they put us into lockdown and they break all our contact with people, it stops all that spreading to multiple people. So that's an exponential, something that starts slow, and then as more people get infected, it takes off. Okay, head lice is another one often used for an example, because as you know, if you ever had head lice, if you get one egg in your hair, that will crack open, and then that lice will lay more eggs, and so on and so forth. So any type of bacteria in science, any type of bacteria you put into a petri dish, that generally splits and multiplies. So all of them are examples of exponential curves, and you'll know it from the numbers increasing here rapidly. So you see 2 to 4, not that great of a jump. 4 to 8 is okay. 16, then we start to get very high. Now I have 64, all of a sudden I have 128. Then I'm in the 200s, then I'm in the 500s, then I'm into the thousands, then I'm into the 2000s. So that graph is most definitely an exponential growth, because the range increases dramatically. It doubles for every value of x, or for every fold, whichever way you want to say it. Okay. I hope that's okay. And that concludes that question.